In this EzEd video lecture, we will see what is impact and line of impact, types of impact, direct central impact and oblique central impact. Two meteors in space are on a verge of collision. When the collision of two meteors takes place during a very small interval of time and during which the colliding meteor exerts relatively larger force on each other is known as impact. And when two bodies collide, the line joining the common normal of the colliding bodies is known as line of impact. Let us now understand different types of impact. Consider two meteors are on verge of collision. When the mass centers of the two colliding meteors lie on the line of impact, the impact is said to be a central impact. Now again, considering two meteors collision, when the mass centers of the two colliding meteors are not located on the line of impact, we call such an impact to be an eccentric impact.
Hey, it's time to concentrate now.
Let us now study the phenomenon of a direct central impact. Ball A and ball B are moving with velocity VA and VB. Here, velocity of ball A is greater than velocity of ball B. When the two balls come in contact, that is the period of deformation and the period of restitution. On impact, deformation begins. During the period of deformation, the two balls exert large impulsive force on each other. The deformation of both the balls continue till maximum deformation. For a very small interval of time, they move with common velocity. Now the period of restitution begins. The two balls restore their shape during this period. Sometimes, permanent deformations are also set in the particle. During this period, the impulsive force exerted by the ball is lesser than during the period of deformation. At the end of restitution, the two balls separate from each other. Now the two balls move with new velocities VA' and VB'. So these are the various periods that take place during direct central impact. Coefficient of restitution shows nature of the body. Restitution is defined as the ability to restore to its original shape and size. The value of coefficient of restitution varies from 0 to 1. If E equals 0, the body is referred to as a perfectly plastic body. If E equals 1, the body is referred to as a perfectly elastic body. Consider a crazy ball and a basketball, whose coefficient of restitution is 0.95 and 0.75 and are released from the same height. Both will bounce, but the crazy ball will bounce higher than the basketball. Crazy ball bounces higher since the value of coefficient of restitution is close to 1. Consider two balls, red and yellow, moving with velocity V1 and V2. The red ball is moving faster than the yellow ball. We will consider three cases where both the balls are moving in the same direction. Both the balls moving in the opposite direction, and the yellow ball is kept stationary and the red ball is moving. Since the red ball is moving fast, both the balls will collide soon. On collision, the red ball will exert force on the yellow ball, and so the yellow ball will exert force on the red ball. After the collision, both the balls will move in the same direction, but with different velocities. Since the red ball is moving fast, it will continue its motion in the same direction. In all the three cases, momentum is conserved and there is loss in energy during impact. In all the three cases, the coefficient of restitution is between 0 and 1. Equation for coefficient of restitution is given as difference in velocity after the collision divided by the difference in velocity before the collision.
Seriously, pay attention. This is important.
Let us understand the steps to solve the problem on direct impact. The given data will be the velocity of the bodies before impact, coefficient of restitution E, and we have to find velocity of the bodies after impact. Step 1. Since there are no external forces acting on the colliding bodies, the momentum of the system is conserved, that is, conservation of momentum is applicable. Initial momentum equals final momentum. Step 2. Use coefficient of restitution equation. Step 3. Solve the two equations and find the velocities after impact. Note: take proper sign conventions for the direction of velocities while using the conservation of momentum and coefficient of restitution equation. Let us solve a problem on direct impact. A 3 kg ball moving with 0.5 meter per second towards right collides head-on with another ball of mass 5 kg, moving with 0.7 meter per second towards left. Determine the velocities of the balls after impact and the corresponding percentage loss of kinetic energy when the impact is perfectly elastic, the impact is perfectly plastic, the impact is such that E equals 0.7. According to the problem given, this is the case of direct central impact. First case, the impact is perfectly elastic. Step 1. Since the momentum of the system is conserved using conservation of momentum equation, that is, initial momentum equals final momentum, on substituting the respective values, we get equation 1. Step 2. Using coefficient of restitution equation, on substituting the values, we get equation 2. Step 3. Solving equation 1 and 2, we get the velocities after impact. Since the impact is perfectly elastic, there will be no loss of kinetic energy. Second case, impact is perfectly plastic. In this case, the particle moves with common velocity after impact as shown. Now, using the conservation of momentum equation and substituting the values, we get the velocity after impact. Since it is plastic impact, there will be loss of kinetic energy. So, the kinetic energy of the system before impact is given as follows. On substituting the values, we get kinetic energy as 1.6 joules. Now, writing kinetic energy of the system after impact and substituting the values, we get the kinetic energy of 0.25 joules. So, the percentage loss in kinetic energy is 84.375%. Third case is E equals 0.7. Step 1. Since the momentum of the system is conserved using conservation of momentum equation, that is, initial momentum equals final momentum, on substituting the respective values, we get equation 3. Step 2. Using coefficient of restitution equation, on substituting the values, we get equation 4. Step 3. Solving equation 3 and 4, we get the velocities after impact. Here, the kinetic energy of the system after impact is 0.9115 joules. Therefore, the percentage loss in kinetic energy is 43.03%.
Hey, it's time to concentrate now.
Suppose the two balls are coming from an angle and collide. That is, both colliding particles are not directed along the line of impact. The impact is said to be an oblique central impact. The velocities in the y direction, that is along tangent, do not change after the impact, since they are perpendicular to the line of impact. Let us understand the steps to solve the problem on oblique central impact. Step 1. Let the line of impact be now called as normal direction of impact. Let its tangent be the direction perpendicular to the normal direction. Step 2. Resolve the initial velocities VA and VB along the normal and tangent direction so as to get their component. Step 3. Work as direct impact problem in the normal direction and take only initial velocities. Use conservation of momentum and coefficient of restitution equation and find velocity component after impact. Step 4. Work in the tangent direction. Since velocities doesn't change in tangential direction, velocities in tangential direction remain the same. Step 5. The magnitude of velocities after impact is given as follows, and the new direction of velocity is given as shown. Let us consider a problem on oblique central impact. Two smooth balls collide as shown. Find the velocities after impact. Take mass of A as 2 kg and mass of B as 3 kg and E equals 0.7. We can see that this is the case of oblique central impact. Step 1. Let the line of impact be in normal direction and a perpendicular to it be in tangent direction. Step 2. Resolve the initial velocities along normal direction and tangential direction. We get the following values. Step 3. Work as a direct impact problem in the normal direction and take only initial velocities. Using conservation of momentum and substituting the values, we get equation 1. Now using coefficient of restitution equation and substituting the values, we get equation 2. Solving equation 1 and 2, we get the velocity component after impact. Step 4. Work in the tangent direction. Since velocities don't change in the tangent direction, velocities in tangential direction remain the same. Total velocity VA is given as shown. On substituting the value, we get value 2.71 meter per second. Now, the angle at which VA vector will act is 47.54 degree. Similarly, finding the velocity and angle at which the VB vector will act. A combination problem is the use of all the three methods which we have learnt in kinetics of particles using Newton's second law, work energy method and impulse momentum method. We have also seen conservation of energy principle and conservation of momentum principle, which help us to give quick solutions. Consider a problem where a sphere of mass 3 kg is released from rest. It swings as a pendulum and strikes a block B of mass 2.5 kg resting on a horizontal surface. Determine how far the block will move after impact. Take mu equals 0.3 between the block B and the horizontal surface and E equals 0.75. This is a combination problem where velocity of the sphere is found using work energy principle. On impact, we will get the velocity of the sphere and the block, and again using work energy principle, we will find the distance travelled by the block. Applying work energy principle to sphere A from position 1 to 2. At position 1, kinetic energy is 0 since it starts from rest. At position 2, the sphere will have kinetic energy. Here, work is done only by weight force. On substituting the values in equation 1, we get velocity of sphere at position 2. Now, there is impact at position 2. Sphere A will strike the stationary block with velocity 5.425 meter per second, causing direct central impact. Step 1. Use conservation of momentum equation. On substituting the values, we get equation 2. Step 2. Use coefficient of restitution equation. On substituting the values, we get equation 3. Step 3. Solving equation 2 and 3, we get the velocities after impact of sphere and block. As sphere strikes the block, there is work done by the block. So, we will apply work energy principle to the block. At position 2, block will have kinetic energy because of impact. At position 3, block will come to rest, therefore no kinetic energy. Here, work is done only by friction force. Substituting the values in equation 4, we get the displacement of block. Let us take a quick overview of this EzEd video lecture. We have seen what is impact. That is, when two bodies collide for a very small interval of time, it is known as an impact, and the line joining the common normal of colliding bodies is known as line of impact. And types of impact like central impact and eccentric impact. In direct central impact, we have seen how a ball behaves during impact. A ball undergoes various stages during impact. Stage 1. Balls before impact. Stage 2. On impact, deformation begins. Stage 3. At maximum deformation, restitution period begins. Stage 4. Restitution period ends. Stage 5. Balls separate and move with different velocities. And also we have seen steps to solve problem on direct central impact. Step 1. Use conservation of momentum equation. Step 2. Use coefficient of a restitution equation. Step 3. Solving the two equations, we get the velocities after impact. In oblique central impact, two balls collide at a certain angle. And also we have seen steps to solve problem on oblique central impact. Step 1. Locate the normal direction and tangential direction. Step 2. Resolve the component in normal and tangential direction. Step 3. Work as a direct impact problem using respective formulae. Step 4. Velocities do not change in tangent direction. Step 5. Find the magnitude of new velocities and its new direction. A combination problem is the use of all the three methods which we have learnt in kinetics of particles using Newton's second law, work energy method and impulse momentum method. We have also seen conservation of energy principle and conservation of momentum principle, which help us to give quick solutions. So this is the overview of our video lecture.